Good day, Niners. In this video lesson, we'll be answering some basic application problems involving right triangles. So particularly these two, we have bearing and the angle of elevation, depression. So bearing. The bearing of a line in the horizontal plane is the acute angle made by this line from the north-south line. So that's why it's in bold letters. It's very important. It should be measured from the north-south line. We'll see later. Angle of elevation, angle of depression. When the object observed is above the horizontal plane, the angle between the line of sight from the eye to the object and the horizontal is called the angle of elevation. When the object observed is below the plane, the horizontal plane, the angle is called the angle of depression. So it's simply when the observer is looking up, it's elevation, and the observer is looking down, depression, and what's more important is that the angle should be measured with the horizontal. Let's have the problem solved. An airplane is 115 miles due east of radio station A. Okay, so let's have this red dot as the position of station A. Let's call it point A. Then 115 miles due east. So we have here due east. So we have just have this blank 17, and it said there's the airplane. A second radio station is 136 miles due north of A. So from A, there are reference point due north somewhere here. Let's have this as point B where the second station is. And the length of this is 136 miles from distance from A to B. So the questions are simply what are the distance and bearing of the second radio station from the airplane, meaning the distance of point B to the airplane. So the distance is pretty much very easy to get. So it's simply your basic Pythagorean theorem. So we have here the square root of 136 squared plus 115 squared. So the distance is simply okay. Now you get your calculator ready and please solve the value with me. So it's simply square root of 136 squared plus 115 squared. We'll get here up to 2 decimal places. 178.10. So it's done. So what's more important in this example problem is how to get the bearing of the radio station from. So that's the keyword from the airplane. So meaning this should be your reference point. Remember, this is your reference point. You have to there. So from this point, the bearing of this line to the reference point. Now, first we can get the angle using our basic tangent function, which is tangent of the angles opposite over the adjacent side, which are already given. So we can also use the D. So we can use cosine and sine, but it's already provided. So it's pretty much the easier way. Tangent of the angle is opposite 136 over 115. So then again, to get the value of the angle, we simply use the inverse function of tangent. This is tan inverse 136 over 115. So again, calculators ready. So you get here 136 over 115. We get up to 2 decimal places. We can get the value 49.78 degrees. But this angle is not your bearing, because the bearing should be measured from this line. So this should be what we need. This angle is called angle theta. And the bearing of point B from the airplane must be from the north line going to the west. And we supply here the angle alpha which is just the complementary angle of theta, which is 90 minus 49.78. So you get here 40.22 degrees. So here should be 40.22 degrees west. So this is the bearing. So remember that the bearing should be measured the acute angle from the north-south line. Let's have the next problem. From a mountain 1,780 feet high, the angle of depression of a point on the nearest shore of a river is 48 degrees 40 minutes, and of a point directly across on the opposite side is 22 degrees 20 minutes. What's the width of the river between the 2 points? Now let's have just a quick sketch of what's going on. So I have here, let's say this is our mountain, that's the top of our mountain. So if someone is here observing, looking down, there's a river on the level ground, and this here, looking at the nearer shore, says the angle of depression is 48 degrees 40 minutes, meaning this must be that angle. Again, should be made with the horizontal, 48 degrees 40 minutes. And the depression, the angle of depression to the point directly across on the opposite side. So that's why this is smaller. So let's say this must be that angle. This 22 degrees here, 20 minutes. Okay, now let's simplify the figure into what we know. Simple right triangles. So basically what we have would be okay, so we have let this be the height of the mountain. Okay, this is our level ground. This point right here, say here, this is the nearer shore, and this is the opposite side of the shore. So we have here this and this as our line of sight. Okay, remember that we have here an angle of depression. Let's say this is the angle of depression theta. Remember with the horizontal. Remember that if you draw up the line parallel to the horizontal, meaning the ground, what we have are simply two pairs of a pair of alternate interior angles. So meaning these two are the same. So if this is 48 degrees 40 minutes, then this must also be 48 degrees 40 minutes, simply because they are alternate interior angles. So there, so we have, okay, so we have the triangle now. So we know that this angle will be 48 degrees 40 minutes, and this angle must be 22 degrees and 20 minutes. And of course, the same height of the mountain, we have 1,780 feet high. Now, to further simplify the problem, let's have these two right triangles drawn. So let's say this triangle will be, of course, you know, this would be that triangle, and then another bit longer triangle to represent this whole triangle. So we are asked to find the width of the river, which is the distance between two red points, that is bx. And we don't know this point also, which is the distance of this point, the nearer shore to the base of the mountain. Let's have this as y. So in this triangle, this must be that length y. The height is 1,780. Of course, it's also 1,780. So what do you think would be the length of this side? Which is, of course, this. So which is x plus y. So we focus on solving these two triangles. Let's just move it here and erase. Okay, now remember, there are different angles. This is the larger one, 48 degrees 40 minutes. This is the smaller one, 22 degrees and 20 minutes. So we're using the trigo function tangent of the angle. So tangent 48 degrees 40 minutes must be using, in this triangle, opposite is 1,780 over y. So now we can solve for the value of y, which is simply 1780 over tangent 48 degrees and 40 minutes. So again, bring out your calculators and let the calculator do the work. As much as possible, you use your calculator using natural display. So here you get the value of correct up to 2 decimal places for y, which is 1565.60 feet. Now we are asked to find the value of x, not the value of y. So we shift to the other triangle, which is this triangle. This time the tangent of the given angle 22 degrees 20 minutes, and it's equal to 1780 over x plus y. Okay. Now we can simply solve the value of x plus y first, and then since we know y, we subtract it from the value, this value, and that will be what's desired, what's asked in the problem. So to illustrate, let's just represent this as, let's say, a. So x plus y is a. So just do, so we remember. So from here we can get the value of a, which is 1780 over tangent of 22 degrees and 20 minutes, and we will get, again, calculators out. So we have tangent, yeah, that's my knee. We have here 4332.91 correct to 2 decimal places. So remember that we have the value of y, we have a, so what is x? So x is simply a minus y, and it's 4332.91 minus 1565.60. So x is equal to 2767.31 feet, which is the width of the river. So you see, a complicated problem like this can be solved by simply representing them into simpler right triangles. Okay, I have another problem, but we only have 2 minutes left. So you can solve this problem as an exercise for an angle of elevation. So remember, applications, angle of elevation, depression, and bearing. Do not forget the important notes I put here, the bearing and elevation, depression. Good day, Niners.